So I will welcome now one of the keynote speakers that is, I consider the person that knows more about artificial intelligence, and not only in Portugal. I would like to introduce to you Professor Arlindo Oliveira. He has been the president of Instituto Superior Técnico, and he's the president of INESC Group. He's a member of the board of the Caixa Geral de Depósitos. He's a very well-known researcher, not only in Portugal, but also abroad. He authored 3 books. I really recommend especially for students but not only for students, to read one of his last published books about artificial intelligence. These books were translated into different languages, so you can have it in Portuguese as well. You can buy it on FNAC. He is the panel of the European. He has been on the advisory member of the National Council for Science, Technology and Innovation, and a member of the advisory board of the Science and Technology Options Assessment Panel of the European Parliament. He is also past president of the Portuguese Association for Artificial Intelligence. He was the head of the Portuguese node of the European Network for Biological Data and visiting professor at Massachusetts Institute of Technology and University of Tokyo. And he has been a researcher also linked to the Center of Research on Space in Europe, Cadence Research Laboratories, and Electronics Research Labs of the University of Berkeley in the US. And he's a member of the Portuguese Academy of Engineering and a senior member of the Institute of Engineering. So he received several prizes and distinctions, including the Technical University of Lisbon Santander Prize for Excellence in Research in 2009. But apart from that, our invitation to Professor Arlindo Oliveira had to do with the fact that he is a member of the European Consortium for Artificial Intelligence and Ethics. And this is one of the issues that I would like to introduce first thing in the morning, because we talk a lot about technology and about how machines are going to dominate the world. And but the world was made, I think the most beautiful things in the world were made by men, and having the humankind as the objective. Machines may have the ability to think in terms of machine learning. We may have machines that have some kind of intelligence, but for marketing students, they know that machines are not going to buy anything in the future. Machines are not going to be enthusiastic or emotional about a sunset, or not to make their way to a spa in the Caribbean. So I think there is some kind of distance in terms of what a machine can do and what we can do and will do with the future, because the future is in our hands. We cannot be afraid of the future, because the future is not a given fact. It's something that we build every day with our actions, with our activities. I would like very much to thank and welcome Professor Arlindo Oliveira. Thank you so much for being with us today.
Thank you very much. Good morning, everyone. So Thank you for the invitation. I'll try to share with you some of what is artificial intelligence and also the enthusiasm that we have for this topic. I will try to share my screen. Let's see whether this works. I think you should be able to see my screen now, hopefully. What I'll try to do in this talk is to give you some ideas of the technologies that are behind today's artificial intelligence techniques, and also applications and some of the ethical implications of this technology. First of all, it's always difficult to make predictions, and about AI, it's inevitable to make predictions because it's something that is evolving so rapidly that you cannot only think about today's technology, but what will happen tomorrow. And it is very, very hard to extrapolate the future of technology because in the past we have been systematically wrong about what happened with specific technologies, electricity, automobiles, nuclear, and so on, computers. So all these technologies have actually evolved much more and in different ways from what we expected. In part, this is due to what is called the Mara's law, that we tend to overestimate the effects of a technology in the short run and to underestimate the effect in the long run. If we imagine some technology that is developing as the blue line, in this case it's an exponential technology, but it doesn't matter really, and we know where it will be in 10 years, we tend to be somewhat optimistic of where it will be in 5 years, maybe. But then when we extrapolate this tendency to 20 years or to 40 years, we can see that our slightly optimistic in the short term interpolation is actually very pessimistic and actually totally wrong in the long term. And this has happened with automobiles, with electricity, with computers, with transistors, with planes, with everything. All these technologies have evolved and changed with smartphones. So nobody could have imagined when smartphones were introduced less than 20 years ago that society will be so different today, only 20 years after the introduction of smartphones. One of the best known exponential laws is Moore's law. Moore just died a few weeks ago, actually, Gordon Moore, and he proposed this observation that the number of transistors that you can pack on a given size of an integrated circuit doubles every year, and that has been every 2 years. It doubles every 2 years, and this doubling every 2 years actually has been happening for 60 years now, which means that it has doubled 30 times, which means that we can now have 1 billion times more power in a given chip than what happened in 60 years ago. This is what you can see here is the number of transistors that were manufactured on the planet up to some year. You see there a rapid growth in 2000. But actually, this rapid growth, this is an exponential curve. This is the rapid growth that keeps happening. It's the same thing in 2010, it's the same thing in 2020, and maybe it will still be the same 6 years from now, even though it will eventually slow down to the limits on the laws of physics. And it's due to this exponential growth of the abilities of computers that we have been able to work on artificial intelligence and to try to realize what is actually an ancient dream of humanity, which is to create machines that are intelligent. And the first of such machines have been referred in Greek texts in ancient Greece, although they were only literary works. Other machines have been proposed over the past centuries to automate some of our ability to compute. The Pascal made the Pascaline. In the 19th century, there was a mechanical computer that was planned and even programmed by Ada Lovelace. But it turns out that only after the middle of the past century that we were able to actually start to realize this dream, we can call it that, of making machines behave in intelligent ways. It's even hard to describe exactly what this is. What is it to behave in an intelligent way? But in general terms, it is machines that can do things that require intelligence if done by humans. So this is a somewhat circular definition, but is the best we have for what is artificial intelligence. So in this 70 years of history of AI, there has been significant times of despair, and also times of enthusiasm. We are now living, since about 10 years ago, a very an epoch of great enthusiasm, and you can see that these trends, these new technologies like deep learning, neural networks, machine learning are actually developing very, very fast. We had these winters of AI when it was research in AI dried out, funds dried out. And one of the reasons we had these winters, these times when it was believed that up to some point that it was an impossible challenge, was because of what is known as Moravec's paradox. So Moravec was a professor at MIT, and he wrote something that it's strange that things that are easy for us to do are difficult for computers, and vice versa. Like proving mathematical theorems or playing world-class chess is actually relatively easy to program, while recognizing faces, understanding scenes, or just understanding speech or spoken language is actually very hard to program. And what has been happening in the last 10 years is that for the first time we are able to do these things that have been so hard for us to program. And we have been with a particular technology that is called mostly machine learning. So AI is actually has many subfields. It includes search for solutions, reasoning about facts and rules and so on, processing natural language, computer vision, robotics. But machine learning is really the technology that is behind today's advances in artificial intelligence. So when we talk about artificial intelligence, it means many things, and so sometimes it's hard even to understand exactly what is artificial intelligence, what is AI. So I usually organize artificial intelligence in three large areas, which I call analytics, automation, and artificial general intelligence, the three areas that are there. In the middle, we have those technologies that I made a reference to: machine learning, perception, search, natural language processing. And these technologies have applications in these three large areas. The first one is analytics. It's this idea that you can organize data, and organize data in such a way that you can use it to optimize, to create economic value, to optimize sales and marketing, to optimize processes, to obtain new drugs, new laws of physics, new knowledge, to analyze social behaviors, influence them elections, influence society, to perform financial analysis. This is the big area of analytics. It is due to this ability to organize data, most of it provided by citizens for free, that the largest companies in the world have their value. So Google's, Facebook's, Amazon's, all these companies owe the value they have, which is in the $1 trillion range, to the fact that they are able to organize and resell this data. And so well, this is just a few jokes, right? Google, no hiring, no need to apply. We already have all the information about you. Or Facebook, that there's Mark Zuckerberg. My dad told me you're spying on us, and he said, well, it's not your dad. It's just an illustration that these companies have lots and lots of information in each one of you, and they use this information to generate money, basically by selling this information to the highest bid. The central idea, the central business idea, is that we should have 360 degrees views of customers, that every customer, every process, every supplier should be well known. We should know his or her demographics, the transaction history, the needs, the propensities, how they responded to previous campaigns, how do they interact with the companies, and so on. And this 360 degrees views of customers is fundamental for any company these days, and you cannot be a competitive company in an international setting if you don't have this. The second area of AI is automation, and this is a slightly different idea, that we should be able to automate a number of tasks that are done by humans, like customer service, attending calls in a call center, or driving cars, or doing errands and tasks that as personal assistants, or analyzing legal texts, or just many specialties of medicine like radiologists, cardiologists, and neurologists. So all these areas are actually rapidly being automated. We are rapidly having systems that can diagnose illnesses, that can pass tests, that can pass, for instance, the medical licenses, business degrees, and the bar exam in the United States. I have some more to say about this, but the key point is that we have now systems that can do many of these things that are normally done by humans. So the companies here are just a few companies that are exactly in this area, that are automating customer interaction. Omili, Agentify, and TalkDesk, NeuralShift. They are all companies, Portuguese companies, that were created using these technologies to partially or totally automate parts of jobs that are done by humans. And then the third area of artificial general intelligence, is this idea that as we keep developing the technology, we should reach a level of human level intelligence with the flexibility and that adaptability of human intelligence, which of course raises an open-ended possibility, right? And the systems will have, if we ever get there, the same creativity, the same way to interact, but of course they'll be more flexible in many respects. So all these areas have significant and raise significant challenges, ethical and social challenges. The first one, analytics, raises very serious privacy issues, as models of each one of us are owned and maintained and kept up to date by these big companies. But to me, even worse are the risks that come from information bubbles, from the fact that each one of us basically gets informed by very specific tailored channels that send information to each one of us in a specific way. And this leads to echo chambers and an ability to see other parts of the information, other views of the same facts, and leads to radical positions in politics and to difficulty in dialogue. And I think in the end, it's a risk to democracy. And we are seeing this in the United States, we are seeing this in Brazil, but we are also seeing this in Portugal and in Europe to a less degree. We have seen this in Brexit. So these people see totally different information, they have totally different positions, and they cannot compromise, they cannot dialogue with other people because they believe, some people believe the earth is flat, other people believe that the US elections were stolen, and they really believe this because they are only exposed to information that confirms and reinforces their beliefs. So the secondary automation also raises some obvious risks. The first one and most obvious is the unemployment risk, that people will be automated out of their jobs. Not a problem that is very visible still today. On the contrary, we are facing severe labor shortages in many fields. But it also raises other issues like inequality and power concentration, as the largest companies employ less and less people, paying higher salaries and higher returns to shareholders, but concentrating economic power. And of course, there's a problem of biases when these systems that are trained to perform human functions are trained on biased data and can themselves create biased decisions. And then at AGI, artificial general intelligence, leads to some obvious risks of the loss of control, of the loss of relevance, and possibly of humanity, and certainly security risks, as these systems can take possibly more and more control of critical facilities in our infrastructure, like energy, water, communications, or even weapons. So behind the advances in artificial intelligence today, we have this machine learning technology. There are several types of machine learning. The most well-known and most powerful is supervised learning, where you have a teacher, but there's also unsupervised and reinforcement learning and other variations. What is exactly supervised learning? And I will concentrate on this one. So machine learning is this idea that you can, instead of writing a program for every specific application, you can actually just show a machine learning algorithm, the blue box in the bottom, You can show it many pairs of input-output, for instance, X-rays and the diagnostic associated with each X-ray, or maybe questions and answers, right? The inputs are the questions, the outputs are the answers. And the machine learning algorithm generates the program, the program that transforms the input into the output. Pedro Domingos called this the master algorithm, the machine learning algorithm, because it is able to learn anything. And this is actually the way the human brain works. We learn to do things as we grow, as we interact with other people, as we are trained and study. And Alan Turing, in a very influential 1950 article, said that if we want computers to behave intelligently, maybe we should program the ability to learn, and from this ability to learn, they will learn to behave intelligently. These two ways of learning are related with two different things that we know. For instance, we know the declarative knowledge that is learned in books and formally, and we know how, which is something that we learn by experience. And so now computers can not only have declarative knowledge that is in text and documents and models and programs, but they can also know how with experience. And this is creating this ability. This is replacing the Kant's deduction process by Hume's induction process. And actually the computers now have both and become very powerful. You can also have this supervised learning delayed in time, where instead of teaching the computer, when on the examples you let the computer do a number of tasks, for instance, playing a game, and then in the end you tell it if it won or lost, and then it can assign credit to the actions that it developed. And you can even learn without a teacher, although I don't have that slide, which is good. You can even learn without a teacher by looking for regularities in the data. So there are many methods to perform this machine learning. I usually classify them in four categories. The ones that symbolic methods that derive symbolic representations, statistical methods that derive statistical descriptions of the data, methods that work by analogy, and the methods that have structures that are inspired in the workings of the human brain, even though it's a distant inspiration by now. So symbolic methods generate things like decision trees, and methods that work by analogy usually store the data that was used to train them and then look for analogies between the new cases and the data that is stored. Statistical, like the naive Bayes or Bayes networks, basically learn statistical descriptions of the data and can use those statistical descriptions to infer the properties of the data. And connectionist methods are based on models of the human brain that are trained in a way that I will describe. So this is just an example of decision tree, for instance, in this case, that decides whether a given person is or is not cheating on his taxes declaration. And from a table, you can derive the tree on the right, which is useful because it's understandable. It, for instance, can be used in medical diagnosis, but it's a summary of the table. The table is very small in this case, but the table can have millions or even billions of entries and be summarized in a tree, in a decision tree in the right. This is the method is called nearest neighbor, where you decide by similarity. So you look for points, and if they are near a blue point, you'll say that they are blue, and if they are near a red point, you'll say it's red. Usually the points, the data does not have only two dimensions, as is the case here. You can have hundreds, thousands, millions in some cases of dimensions, but the principle is the same. The regression is a good example of a statistical method where from specific cases you infer a general rule, a general relation between the input and the output. In this case, it's a single variable regression, but you can also do it with multivariable regression and logistic the type of regression. And finally, neural networks, which are actually the workhorse of today's AI, are based on simplified models of neurons in the brain. So these simplified models of the neurons basically take several inputs. These inputs are weighted. There are weights in these inputs, and then they go through some nonlinearity. Each individual neuron, artificial neuron, just does a very simple mathematical operation like this. It breaks a volume into two half volumes. or hypervolume into half hypervolumes. But if you interconnect several of these networks, of these neurons, artificial neurons, and then you program this network of neurons by setting up the right weights that interconnect the neurons, then these neurons learn to make fairly complex mappings, and these mappings can be used in computer vision, these mappings can be used in natural language processing, and in many other applications. I think I have a video here of a very small neural network. I think you can see it. So every one of these small white points is one of these artificial neurons. It was trained to recognize handwritten digits. This is a very small neural network, has only 10,000 neurons. Right now we are talking about this one has 24 million parameters, but right now we are working with networks that have billions or hundreds of billions of parameters, or even trillions of parameters, much more complex than this one. If you use many layers of this, it's called the deep learning, deep neural networks, and that can be used, as I said, in many applications like face recognition, surveillance, many applications in computer vision, and spoken language processing. Right now, what is happening is that we have the convergence of three factors: very fast hardware, namely GPUs, that were graphics processing units developed for games. We have lots and lots of data that is coming out of cell phones and computers and sensors everywhere. And we have better algorithms. And it is this convergence of these three factors that is causing the deep learning revolution. We have many architectures. So for these artificial neural networks, have architectures like GNNs, RNNs, and so on. The two most popular ones are the convolutional neural networks and the transformers, and I will focus on those two. Convolutional neural networks are mostly used for computer vision, but also used in other things like in games and so on. And they have names like Inception, ResNet, VGG, and so on. They can be downloaded, pre-trained or not, and applied directly in many applications. Any computer science student can download one of these models and use it in a new application that you dream of in computer vision or so on. And we also have the transformers that have been proposed. The CNNs are actually fairly old. They are more than 20 years old. But transformers are relatively recent. They were proposed in 2017. And they have been revolutionizing the processing of natural language. They were proposed first for translation, but we have learned in these years that they can be used as these language models can be used in many other tasks. The way they work is that in language is that the input is a sequence of words. Each particular word is embedded in a space. Here is an illustration of an embedding in a space of 2 dimensions, where you can see that words that are similar are embedded in similar parts, in close parts of the space. In reality, those embedding spaces are much higher dimension. They can range from 1,000 to 12,000 dimensions. So we are talking about very high dimensional spaces where each word is embedded. And it is in this high dimensional space that words acquire meaning, because, for instance, king and queen, they are nearby, and man and woman, and there are relations between this. So these systems learn the meaning of words by embedding this into these high dimensional spaces. Very likely how happens in our brain, although we don't know about that. And then they use a called self-attention mechanism, which enables these systems to relate the words that have meaning. For instance, in this sentence, the animal that starts the sentence then is related with the it in the middle of the sentence. So this is the way these models have to understand language. And so all this, if you have, for instance, a sentence like this, it goes through a transformer with these mathematical operations, and in the end, it enables you to do one very simple thing. Okay, so when we have large language models, so what we have been seeing with GPT-3 and ChatGPT and GPT-4 is that these models have an ability to predict missing words. And in particular, they can be trained to predict the next word in a sequence of words. Okay, I will skip this. Those are some of the applications that in machine learning, some of them I refer to in gaming, in self-driving, in medicine, and so on. But let me just go a bit more in detail into some of these applications. For instance, in computer vision, this is an application that was developed by a company started by students of mine. What basically they do is that they do automatic detection of damage in vehicles. So people can send pictures and the system will detect where are damages in vehicles. This is another application in the prediction of stroke effects. So it's a competition, worldwide competition, where our system won the first place for being able to predict what regions of the brain will be affected for a stroke 3 months in the future. And you can see on the right the ground truth and on the left the prediction, which is not perfect, but is good enough. It was the best that we were able to do. This is another system that we developed that identifies the stenosis, which is this narrowing of the coronary arteries, and this is done automatically from the images on the left that you can see are very hard to understand. The image is segmented, and then this narrowing of the arteries is automatically identified by the systems and can support or even replace in some cases the analysis of a doctor. But really what you probably want to do is what are these large language models that have been all the rage in the last 6 months. Actually, they have been around for a long time. And GPT-3 has been around for 3 years. We were able to use GPT-3, which is almost as good as ChatGPT, for 3 years. So this enthusiasm that we have seen in the last 6 months came as a surprise to the community that knew about this for actually more than 3 years now. GPT-3 in particular, which came out, well, in the summer of 2020, it's a transformer-based model that has 176 billion parameters. It was trained, as I said, by setting up the weights, these 175 billion weights, using a mathematical method known as gradient descent. It was trained in text that if one person were to read it, will take about 5,000 years of full time, 24 hours a day reading. So it's hard to imagine the amount of text, the amount of information that was used to train this model. And this model was used, I think I have a slide on that. This model was basically trained to predict the next word. So given any sequence of words, this model can predict the next word. So if you ask it a question, the next word will be the first word in the answer. And then you put that word and then you predict the second word in the answer. Or else you can just instruct it to generate any text according to these predicted word probabilities. You can control its creativity by setting up a temperature parameter. If the temperature is this is an engineering term, if the temperature is high, then it will be very creative, but less factual. So it will hallucinate more. If the temperature is lower, then it will hallucinate less, but it will also be less creative. Okay? But every time you ask, it will generate a different text. It will generate a different answer. So you have basically access to a text generator that can work on any topic or answer basically any question for which it has been trained before. This is just one of the GPT-3 and is one of the latest models in a large sequence of models that we have been having. And actually, this list is not even complete because we already have GPT-4 and other models that are much larger. One of the interesting things is that what you see here in the vertical scale is the number of floating point operations that computers did to obtain these models using this gradient descent technology. And what turns out that this sort of 10 to the 24 floating point operations actually take several months and spend a lot of energy. So each one of these models to be trained costs in the range of millions of dollars, just because of the computers that are needed to train them and of the energy that is spent to train one of these large models. For instance, the largest one here is Palm with 540 billion parameters, even though probably now there are models with even larger sizes. This is, if you don't know, this is those are all the language models, probably not all already, but many of the language models that have been proposed and trained so far. You can see there GPT-3 in 2020, about in the middle to the right, and you can see all these descendants of GPT-3, including ChatGPT, which by now is already old story, and you have GPT-4 in the top, and you have all these models that are variations in one way or the other, some of them specialized. So this also gives you an idea that it's not just ChatGPT. We have tens, dozens, and in the future we'll have hundreds of these models, each one of them slightly different, each one of them with different abilities. So it's not just can we use ChatGPT or not? I mean, it's literally hundreds of different models that have been trained with this technology that is well known. I have been using this example since July 2020. So this is a chat with GPT-3 3 years ago, where it was asked what will be the impact of the pandemic, and you can see that it has a very good grasp of what that impact will be, even though it was trained before the pandemic. It also has a good grasp of what will be the results of printing money to give the affected businesses and workers. It basically predicted that there will be inflation, and that is in fact what we are seeing. You can also ask it many things. You can ask it to write computer code and to write computer code for you. Not always 100% correct, but in general very close, and in some cases correct. So many tasks, because in these millions of texts that it has read, it learns what is computer code, what is a poem. I think I have a poem here, but his understanding is still fairly superficial. Douglas Hofstadter, which some of you may know, wrote in an article in The Economist past July a number of questions that GPT-3 was unable to answer because it did not understand the questions. For instance, the first one, or the second one maybe, when was the Golden Gate Bridge transported for the second time across Egypt? Of course, the answer is never, but GPT-3 answered in this way. So there were limitations to GPT-3. Many of them were addressed by the changes to ChatGPT, and that explains in part why ChatGPT is so popular. ChatGPT was trained with additional data, specifically questions and answers that were designed by humans. Then a reward model, a model to assess the quality of the answers, and then a policy for word generation was optimized using a model that is called human feedback reinforcement learning. So these changes to ChatGPT actually made it work significantly better than GPT-3. For instance, you can see the questions that are tricky. Well, let's go back to this one again. When was the Golden Gate Bridge transported? And GPT-3, you can see it gives the wrong answer, but ChatGPT gives the right answer, and even adds in the end that maybe you have misunderstood or have incorrect information about this. So there is no record of this bridge being transported across Egypt or to any other location. Those are just more examples of the evolution from GPT-3 to ChatGPT, and even any of these systems can actually, as I said, for instance, can you do things in verse? Can you explain the difference between political right and political left within a poem in the style of Shakespeare? And it comes out with a fairly reasonable poem explaining the difference. On the right, they champion tradition and order, believing in the strength of the individual. On the left, they seek progress and equality, working towards a fairer society for all. So this just shows the flexibility and the ability of these systems to come out with new things that were never, text that never existed before. Is not just like a search engine that returns the text. It generates new text in a way that can actually be created. You can also train these systems with images and text. Click was the first such system where you basically use text and images. They were all encoded in these spaces, these high-dimensional spaces I told you about, and they were encoded. They were trained to relate the words with the images, and if this is coupled with a process called reverse diffusion, it can be used both to label images, to describe what is in an image, but also to go in the opposite direction, which is generate an image from a textual description. And this, of course, has many impacts in the arts, in the media, in the communication, because you can now generate images almost for free, and you can and very soon you'll be able to generate videos from simple descriptions. So we are talking about very significant change in the economics of media generation. GPT-4, which just came out a month ago, is even more advanced than ChatGPT. He has a number, we don't know all the details. We know that it passes the bar exam. It passes several advanced examinations in different areas for people that have graduated from college, passes the US medical licensing exam, even a sommelier examination, and the Stanford Medical School reasoning exam. So right now, these systems really pose serious, I mean, they are competitive in what regards language processing with with humans that are specialists in the topics. Okay, this is the exam results of GPT-4 versus GPT 3.5, which is the one used in ChatGPT. On the bottom, you have the list of exams, and you can see the percentile lower bound. That is how many students graded lower than this system on this particular bar. And you can see that in many cases, these systems do, well, in most they are above the average of the student, right? And in many cases, they are almost better than all the students, right? They're close to 100%, meaning that every student got a lower grade than these systems. And this, of course, raises significant challenges. You know, how are we going to assess our students? Those are just some examples of images generated by these systems for a collage of the world that BERT built, where BERT is one of these transformers. This is in the style of DALL-E. This is in the style of Bruegel. So those are images generated by request. They came out in a recent example of the edition of The Economist. You can also, as I said, using several methods like generative adversarial networks and reverse diffusion, generate artificial images. For instance, you can, I will not go into details into this, but for instance, all these images are artificial. These people do not exist. They were generated by these systems. And in the same way that you can generate images, you can also this is an actor that we hired to speak with synthesized voice of Marcel. I don't know if you can hear. I'm not sure whether you can hear well the sound, but let me just show you. So when this is superimposed on our president, you can see this is a fake video. You can see that it's not perfect. We have done this just to show the possibility, but we have to be used to not trust videos or images that can very soon be easily generated. I will skip this, and I will just spend 10 minutes. I think I have 10 minutes on the ethical and philosophical issues that are raised by this technology. So a number of objections were analyzed by Alan Turing in his 1950 paper, whether artificial intelligence could actually be achieved. He answered all these objections, and the objections are basically the same ones that we are making today. The first one that he addressed is a very interesting one. The objection is the following: is man is the sole owner of an immortal soul. No machine can have a soul, and without a soul, you cannot be intelligent. This is the objection he is addressing. He answers this objection by saying that, well, I'm not a theologist. I don't know anything about souls, but it seems to me that when you say that the Almighty can only give a soul to a man, to a person, and cannot give him a soul to a machine, you are putting an unreasonable limitation on the powers of the Almighty. If he wants, he can also give a soul to a machine. Another similar objection that he addresses is that only humans can be conscious, machines cannot, and he answers in a very convincing way that machines can be conscious. There are a few interesting, there is this disabilities objections that, you know, machines can never love eating strawberries and cream, or they cannot never love or be loved or feel pain or joy. He also answers these objections by saying that we just say this because we never met machines that could do this, but if machines were to do this, we'll have to accept. So it's very interesting to read Alan Turing's 1950 paper and these very convincing answers to these diverse objections to the possibility of artificial intelligence. One thing that we don't know exactly how it works is consciousness. We don't know how consciousness works in humans and animals, and therefore certainly not in machines. There is a significant amount of work done in dual process theories that breaks human reasoning, human intelligence in two processes: a system one that is intuitive and fast, that relies on emotion and is unconscious, and the system two that is slow, deliberate, and conscious. For instance, when you are multiplying two numbers, you are using system two, but when you recognize the face of someone, you are using system one. So there are efforts to understand exactly how we use these two systems, even though there are also some discussion on whether there are really two systems or just a continuous of systems that goes from very intuitive to very slow and deliberate. And right now there are dozens of models of consciousness. Some of them are being studied to create consciousness in machines. This is just some of the theories, and this is the number of papers that have been published on theories with names like integration information theory, global workspace theory, and so on. So there is a significant effort to understand consciousness and how we can make machines conscious. And there is even the argument that you will need conscious machines if you want to be sure that they know what they are doing and they can explain what they are doing. This, of course, raises many legal and social challenges. There's a report from the European Parliament in 2016, which raises the number of questions, in particular, whether there should be a new legal status for these systems, different from legal persons and legal corporations, what will be the impacts of these technologies in the labor market, and also proposing systems to register and control these agents. Large language models in particular, they pose a number of challenges, social and ethical challenges. They make it much more easy to create misinformation and can be done in an unprecedented scale. As the technology evolves, its output will become indistinguishable from human output. Right now, it's not. We can see that these systems are usually less creative, less opinionated, less deep in many cases, but as the technology keeps developing and we interconnect these systems with databases and search engines and engineering tools and medical records, they will become much more equivalent to humans in the type of work they can do. Of course, it becomes very difficult to assess whether some work was written by students or scholars or were written by systems like this, and this is a challenge to universities, but also to science and to scientific journals. But actually, my strongest fear is that people will interact more with computers and less among themselves, and that people will be exposed to even less diverse and more tailored contents than today, leading to more radical positions, to more bubbles, and to stronger challenges to democracy. The European Union has created a number of documents about this. There's a coordinated plan on AI that was updated 2 years ago. There was a white paper on 2021 that wanted to make Europe competitive and also make it safe and secure. This transformed into basically 3 documents: the Digital Markets Act and the Digital Services Act that were approved a couple of years ago, and the Artificial Intelligence Act that is still under discussion and that defines a number of risk levels and different requirements for different risk levels, higher requirements for higher risk applications and lower requirement for low risk applications. There is a similar, this Artificial Intelligence Act is still not approved and by now is already obsolete because it does not take into account these large language models. So let's see exactly what comes out of the slow and ineffective legislative process in the European Union, but let's hope for the better. The United States have some similar initiatives, in particular the Blueprint for an AI Bill of Rights that came out in October of last year. There are many ethical challenges that were raised. So this question of granting personhood to an AI machine or of robot is a very complex one. Many people believe it's still too early for this, but I don't believe it's the right time to discuss. Okay. Then, of course, the key criterion is that not only these machines can generate texts and information, but can also have other characteristics like being conscious, having perceptions, feeling sensations. And certainly there's the possibility of a machine being granted a moral status, that is with rights and also with duties, is probably the most compelling ethical issue raised by AI. But there are other ethicals, in particular the impacts on the job market. This is also from a report in 2000, which states that although the technologies of mass destruction by nuclear, biological, and chemical were powerful, but they were also hard to get by. While these new 21st century technologies, including genetics and technology and AI, are very powerful, and they are much harder to develop and to maintain. And so the key point is that this is maybe the first moment in the history of our planet that when a species, by its voluntary actions, can become a danger to itself. And as you have seen by the letters that have circulated and by the positions that have been proposed by the specialists, this is a rather divisive and complex issue. I'm now finishing. I will just briefly stop the sharing and come back in a second. Okay, just give me 1 second. Okay, I think I have that. So there are two interesting ideas amongst many others. One is this idea of a singularity, when you can imagine that could, for instance, come from an intelligence explosion that leads rise to a super intelligence. This idea that if these machines are used to generate the next generation of machines, you can get to a very rapid increase in the ability of these machines, a term that was called intelligence explosion by Irving Jargood in '65, and may lead to a singularity, an idea that from von Neumann that from 1952. Maybe the scale of intelligence, we are not as high as we think at the very top. Maybe we are more above average, and then can have vastly smarter and more intelligent systems that will be able to do science and literature and art in ways that are vastly better than humans. And that, of course, raises an interesting question: what is the role of humanity in our planet? And I will finish now with a short video about this.
In recent years, a few outspoken intellectuals, such as Elon Musk, Sam Harris, Stephen Hawking, Nick Bostrom, to name a few, have voiced genuine concerns for the rise of artificial intelligence, as brilliant minds across the globe are competing to retrace the hundreds of millions of years of evolution that resulted in the human brain. And while many experts have no doubts about machines' ability to achieve human-level intelligence at some point in the future, just as many believe it to be an impossibility. And perhaps it is. Perhaps we are incomprehensibly complex in such a way that we cannot do what nature has done to us. Then again, if random mutations can lead to intelligence, how hard can it be?
And so I finish with this. If you want to read more about this, there are many books about these topics. This superintelligence book by Bostrom is a classic on the risks of an intelligence explosion. Ray Kurzweil has been one of the proponents of the idea of the singularity. There are many books on the economic impacts of AI. This one by Briolfson and McPhee is a good one. This To Be a Machine is an interesting and small book about the idea of transhumanism, that the humanity of the future will not be based on the biological substrate that we have today. The Master Algorithm by Pedro Domingos is a classical book, very good one on machine learning. Life 3.0 by Max Tegmark is on this idea also of intelligence explosion. Very realistic scenario of how it could happen. And then those are two books I have authored: The Digital Mind, published by MIT Press, and AI, only in Portuguese, published by Fundação Francisco Manuel dos Santos. And with this, I finish my talk, and I'm available for questions that you may have. Thank you for your attention if you have not fallen asleep during my talk. Thank you.